Understanding data types. In this nugget, we're going to begin a consideration of database and table design. One of the most important aspects of database design is choosing the correct data type. So this is a particularly important nugget. I'll introduce you to the data types that are supported by MySQL, including string, numeric, and date/time, also called temporal data types. After we've laid that theoretical or conceptual foundation, I'll show you how to implement those data types by using the create table data definition language statement. Uses of data types. We know a little bit about databases, right? A database is formally defined as an organized collection of data that suits a particular business or personal purpose. Moreover, we know that in a relational database system, data is defined granularly into one or more groups of tables, and these tables are related by one or more matching columns. This is the purpose of the relational database system. The problem is we want to avoid data duplication while at the same time reducing user error and data inconsistency. Now, what's going on within a particular data table? You know as well as I do that in a data table, we've got columns of data. Columns are also referred to as fields, and these are going to store granular properties or attributes for some aspect that we're tracking in our system. For instance, we may have a table that tracks customers, or a table that tracks products, or another table that tracks employees. So a question is, all right, for our employees table, what attributes or characteristics do we want to track? We might want to track first name, last name, employee ID number, social security number, street address, department ID, and so on. And it goes on from there. Well, within each column, we have to think to ourselves, well, what do we want to do with that data? For instance, with a user's social security number, are we planning on doing any numeric number crunching with that string? Well, probably not, right? On the other hand, a birth date. Will we do any mathematics with that? Well, probably yes. We may very well do some arithmetic with birth dates, especially with our human resources department. These decisions, among many others, factor into choosing a data type for these fields or columns that we choose when we build our tables in our MySQL databases. Formally defined, a data type is a rule that defines the type of data to be stored in one of your table columns. And as I said at the beginning of this nugget, it's crucially important that you accurately select the best data type for each column in your tables. And here are the three biggest reasons, as I see it, to making the best possible data type choice on the front end. Number one, well, I'm not going to say these are hierarchical. I'll say they all have their advantages. One advantage is by choosing the proper data type for each column, you're making the best or most efficient disk storage decision. As we'll see as we go along here, different data types have different disk storage needs. For instance, as you choose different numeric data types that have different levels of precision, each one of those data types has different footprints. In other words, each data type takes up different amounts of space on disk. Therefore, if you don't need longer degrees of precision to store your numeric data, and you're not choosing wisely, and you choose a numeric data type with a longer degree of precision just willy-nilly instead of a numeric data type with a shorter degree of precision, you're wasting disk space. Similarly, for a string data type to store alphanumeric data, if you choose, for instance, a char instead of a varchar, simply because you don't know the difference or the ramifications in disk storage between those two types, a char 50, let's say, versus a varchar 50, you're consuming 50 characters or 50 bytes of space for every row in the table that has a column of char50. Whereas if you choose varchar50, and let's say you've got rows that only have 3 or 4 characters in them for each row, the rest of those empty characters are not taking up any disk space. More on character-based data types momentarily. So just know right now that different data types have different footprints as far as disk storage, and you want to choose the best data type for the best job to save disk space. And please don't fall into that trap that disk space is cheap nowadays, so we don't have to be parsimonious. I don't buy that at all. We want to be strict about our disk space. Another advantage of accurate data type selection is better data integrity. As a DBA and as a database developer, we need to be always very mindful of data integrity. We want to make sure that all data that goes into our tables is accurate. Now, we can't help it if a business analyst makes a mistake on his or her side and puts in somebody's name incorrectly. However, we want to make sure that we don't make a mistake on our side as a database developer, such that when that business analyst puts in bad data on their side from a logic standpoint, that our data type is incorrect on our side. You know what I'm saying? So we want to make sure that our buckets are properly formatted. So a user is putting in data that should come in as a string, and our bucket is shaped like a decimal, or vice versa. We don't want that to happen. We want data integrity to be proper. And we have plenty of rules called constraints to help that along, and we'll gradually unfold those as we move along in this training. We also have this notion of the collation, which can also be looked at as the sort order. This is something that often confuses newcomers to database administration. They hear these terms character set and collation and they get confused. Bottom line is, a collation refers to a character sort order. So for columns that deal with a string data type, where we're dealing basically with character-based data, alphanumeric data, not just pure numbers, and we're concerned with, for instance, especially multinational organizations that are dealing with multiple languages, and we want to make sure that an alphanumeric sort, either ascending or descending, will sort correctly. We have the ability to change the collation to match the language that's being used. And we'll talk more about collations in a future nugget, so we don't need to get bound up with it now. But this is something that we can attach to a string data type to match the language that's being used. MySQL is particularly good at its handling of collations and character sets. MySQL is truly a global database system in that regard. Speaking of strings, let's take a look at our first type of data type, and this is, sure enough, the string. When we refer to a string, everyone, we're referring to, as I've already referred to, character-based data, or alphanumeric data. We're going to choose a string-based data type whenever we're not interested in number crunching. If you ever have need to do arithmetic, or think you're going to have need to do arithmetic, and we're thinking of stuff like sums, averages, greater than, less than comparisons, not equal to comparisons, anything like that, you'll want to choose a string and not a numeric data type. And some of this stuff, at first blush, isn't so obvious. I'm going to give you an example that's semi-obvious. Think of a social security number. Think of a zip code. Now, if you're really overtired, if you were called into the IT office over the weekend to diagnose and resolve a server crash, and you come in on Monday morning, you're just totally fried, and you're asked to build a table, and one of the columns is zip code, you might just go on autopilot and think, well, all of those are 5 or 9 character digits. I'm going to choose a decimal data type. Wrong. You're not going to do computation with a zip code. You're not going to do computation with a social security number. You're not going to do computation with, say, a credit card number either. You're going to definitely save yourself disk space. Remember, we talked about disk space with data types by choosing a string-based data type. Now I'm just giving you the schematics on this whiteboard. You'll certainly want to check the MySQL reference manual to get all of the skinny as far as the disk cost for all of the data types we're discussing in this nugget. You certainly don't need to memorize all of these numbers for your MySQL exam. As an exam developer myself, that's a really low, cheap way to test people on their knowledge, to ask them to regurgitate numbers. The bottom line, friends, is that you have to know how and why and when to apply proper data types. That's the kind of stuff you'll be asked to apply on your exams. You won't be asked to apply necessarily exact numbers. You'll need to know the general range of these lengths, for instance. You need to know that char is a lot smaller than varchar. But don't get hung up on memorizing exact numbers. That's kind of cheap. Now then, char, as I said, is used for very small, 0 to 255 characters. This FL, apologize for my cramped writing here, that's not a 1. This means fixed length non-binary, okay? And VL, that's not V1 or VH1, it's variable length non-binary. The big thing to remember, the big take-home message with string data types is char and varchar, binary and var binary. Big difference here. Char is fixed length, varchar is variable length. Char means that when you do a char data type, you're always reserving that amount of space on disk for that column. So if you do, like I said earlier, if you define a column of char 10, for every row in that column, you're always reserving 10 characters worth of space. So even if you put in data that just takes up 5 characters worth of space, the rest of that data, 5 more characters, get padded out. By contrast, varchar is variable length character data. And as you see, it goes all the way up to 65,535 characters, so you've got a lot more room to move. Char is very small. And what's more is, you could do like a varchar 250, let's say, and even if you only used, say, 25 in a row, you wouldn't have all the rest of that space padded out and all of that disk space used. You would only be storing, say, 25. And in the next row, if you had nothing, you would be storing nothing in that row. You see what I mean? So a lot of DBAs use varchar almost exclusively for their string data because it's so space efficient. Text, tiny text, medium text, and long text are MySQL specific data types that deal, as you can imagine, with small to larger text-based data. I'm not a fan of these, primarily because although you can index these text data types, these ones do not support default values. And I'm a big fan of default values. We'll talk about defaults later on. Definitely hit up my SQL reference guide if you want more information. But these are additional variable length string data types. Whereas char and varchar are good for string data, character-based alphanumeric data, binary and var binary are directly analogous, fixed length and variable length, but these guys are stored not for alphanumeric character data, but for binary data. Binary is just zeros and ones. This is where you'd store stuff like images, files, and anything beyond just plain text, okay? So this allows your database to expand to store stuff beyond just character data. Now, var binary doesn't have much storage. 65,535 characters isn't a lot. To go beyond that, you've got blob, tiny blob, medium blob, and long blob. Blob stands for binary large object data. That's where you can get into larger stuff like larger files and so on. Var binary is primarily used for encrypted data. If you're going to store encrypted information like encrypted plain text or encrypted credit card numbers and so on. Long blob can store actually up to 4 gigs of binary data. And then finally we have the enum and set. These are pretty handy. These allow you to store list data or set lists. And the bottom line here is that you can actually pre-populate data that goes into that column. So enum is what you would choose for a select one list. Think of this as where your data form, your data entry form would be like a drop-down list box where you click it and you can only choose one. Or it would also be something like a radio button control where you have a list where you can choose only one from a pre-configured list. You'd use the set data type for what's called a binary list where you can select more than one. And that would be useful for a checkbox field where you can select more than one option. So that in a nutshell is how the string data types work. Now let's turn our attention from string data types to numeric data types. As I said earlier, we would use numerics for, well, obviously, numeric data, but more specifically, numeric data where we felt confident we would need to do some kind of computation on said data. Now, numerics can be divided into actually three types of numerics. The first, which is what's on this whiteboard, are referred to bits and integers. Bits were referring to binary digits, which are really just zeros and ones. So we have the bit data type. We can define bit strings of from 1 all the way out to 64. That's got very specialized application, really, in the math science realm and computer science. And then more commonly, though, and for more general application, we've got the integer. Now, integers, as you may or may not know, you probably do, refer to whole numbers. So we're not concerned with a decimal point or splitting numbers. Integers have 5 varieties. We've seen some of these designations, tiny, small, medium, when we looked at the string, tiny, text, so on. Here we have tiny int, small int, medium int, and big int in ascending order. Notice that the disk footprint gradually gets larger from 1 tiny int all the way up to big int, which is 8. Now notice these disk costs aren't given in bits but bytes. So 8 times 8, because 8 bits to a byte. Whenever you define a column as big int, each column, whether you have any data in it or not, is going to occupy 64 bits. That's not insignificant, really. So be very careful. Now, but look at the range. Big integer for unsigned values goes from negative, I don't even want to guess what that number is, all the way to positive. Now, that's another term, signed versus unsigned. Of course, signed refers to negative and positive values. In most cases, you'll probably want to use the signed. The good news is MySQL defaults to signed values. So when you define a column as an integer, you don't have to specify signed. It happens automatically. Note that this table gives you the unsigned value as well. Unsigned would start at 0 and proceed forward in the positive only direction. So to sum up, tiny integer looks like it's 0 to 255 unsigned. Small int goes to 65,000 or so. Medium int, 16 mil. Integer looks like a 32-bit value, 4 billion. And then big integer is just crazy. Haven't actually shown you the syntax for defining a data type yet. In the demo, I'll certainly show you, but let me let the cat out of the bag now. When you're defining a column, you just give the column name. Like, for instance, let's say we were doing an integer column now, and oftentimes I find that I use for my ID column, like let's say we were defining an employee table, and I wanted to define a column called employee ID. I would define the column name, no spaces, I'm a big fan of using the underscore, space, and then the data type. Case doesn't matter here. You can do uppercase int or lowercase int, it doesn't matter. I'm using int, obviously. You can use any of these. Int is normally a pretty popular choice, especially for a table primary key value, because, well, in this case, you can go up to, if you're going to do unsigned, which you probably would for a primary key value in a table, you can go up to about 4 billion. Chances are I'm not going to hit the 4 billion mark in my table, right? So you'd say table column space, data type, and then without any spaces in parentheses, you would put the display width. And the display width would determine the maximum range of that integer value. So if I figured I wouldn't have more than, say, 10,000, I would go for integer 4. So that would go up to 9999. And then I would throw in unsigned to make sure that I went just in the positive direction. Incidentally, if I haven't defined the constraint primary key yet, let me quickly do that. When we build out a table, and again I'll repeat this in the demo, each row in that table needs to be explicitly and uniquely defined. The easiest way to do this, it's not the only way, but it's the easiest and most efficient way, most DBAs would agree, would either to be make use of a column that already exists in that column that provides uniqueness, or to create an artificial or what's called a synthetic column that guarantees uniqueness for every row in the table. After all, if we had an employee table that had a few columns like first name, last name, and department name, how many Johns would there be in a typical roster for a company? How many Smiths would there be? If your company had 5 departments, there's no way there would be uniqueness for every employee in the company. Therefore, we need some identifier that would uniquely identify every row in the table. This is a core principle of database design. Certainly, if we're going to take and use these employees in other tables in our database system. Therefore, we would want to create a synthetic or a separate column that simply uniquely identifies each row. Therein gives us our ID column, our emp ID column, and we can apply a constraint called primary key to that column that tells MySQL this column is special. This column uniquely identifies every row in this table. And that constraint forces any data operator who adds new rows to this column, forces any new rows to adhere to that rule. So if we had 10 rows in this table, employee IDs 1 all the way through 10, and I wanted to put in a new employee, and I tried to put in another employee 10, that insert would fail because of my primary key constraint. I hope that little introduction helped. We'll do more, much more on this stuff as we go along. Purpose of this training is to give you an excellent, holistic introduction, not just to MySQL and get you past the exam, but I want to make sure you're really comfortable with database design and fundamentals of database administration. Lastly, let's take a look at floating point, fixed point, and temporal data types. You'll note that I have an S here next to float and double, and a $ by decimal. This is how I tend to group these and keep these straight in my head. I'll put a line here, and we'll take a look at the temporal ones separately. First, let's look at these floating point and fixed pointers. Now, these guys differentiate from the integer because here we're dealing with, well, this notion of floating point. And point refers to, of course, decimal point. Instead of integer, exact value, no decimal point, no decimal places, here we're dealing with precision. Now, in the literature, you'll see the float and double. Float is referred to as single precision. Double is double precision. Now, does that mean that double gives you double the amount of accuracy? Not exactly. Don't worry about single precision and double precision. This actually deals with computer science nerd stuff, that both of these data types tie in really tightly with your computer's CPU and its floating point processor and so on. Actually, double does go to a greater depth of precision. It can go out farther as far as to the right of the decimal point, but it actually has a much higher disk cost. So the bottom line is float and doubler tend to be used more in the science and math realm and give you higher performance, higher speed. Decimal gives you a little bit less speed but greater accuracy. You wind up with a little bit of a rounding error with float and double. Decimal gives you just exactly what you're looking at. There's no rounding error. If you just do decimal 5,2, that's what you're going to get. So decimal is what you want for currency, for financial applications, and for your money. and this is what you see dollars to donuts being used for financial applications in MySQL. All three of these data types use the syntax you see it right here, where we give the data type and then in parentheses you see two values, precision, comma, scale. A little bit confusing here. The precision, I'm going to cut this down to a more manageable level. I'll call this 5 instead of 10. Refers to the overall number of digits given in the value. So 5 comma 2 would mean 2, 3, 4, 5. The overall level of precision given in the value. The scale is the number of digits to the right of the decimal point. So this is what a 5 comma 2 float would look like. You see what I mean? So if we did a 6 comma 2, it would look like this. 1, 2, 3, 4, dot, dot, dot. You see what I'm saying? So the overall length is given by the precision. So that's going to guide your choice when you choose precision and scale. Precision is the overall length. Scale is to the right of the decimal point. Got it? Now down below we have the temporal data types. Temporal is a reference to time, and sure enough you see date, time, timestamp, and year, and the ranges. These formats ought to be paid particular attention to because these are the default formats that MySQL expects to see upon data entry. These are in fact ANSI ISO standard date-time formats. Also, please don't be confused. You would use these to define date and time columns in your table. And these would be for data input. You see what I mean? These aren't functions necessarily. In other words, let's say you were creating a bug tracking application and you had a field in your data entry form for, let's say, date. So the user would type in the date. You would define incident date for your column and you would choose date as your data type. It's as simple as that. Or if you had an asset tracking or a loss prevention application and you needed a timestamp column, or an inventory application, year, time, you can see instantly where this stuff can be handy. I'll show you some handy functions, speaking of handiness, where you can invoke the current date, the current time, the current year, the current timestamp if you need to. But here we're defining just the data types, which can be looked at as a particularly shaped bucket for data input. The question finally arises, how do we use these data types? Now that we have some of the theory down, what do we do with them? Well, perhaps the most common implementation of the data type is in the create table statement. So therefore, let me draw your attention to the top of the whiteboard. Let me introduce you to this DDL statement. Create table, space, and then the name of your table. Now with reference to case sensitivity, a lot of the case sensitivity in MySQL deals with the host operating system, whether you're on Windows, NIX, Mac OS X, and some objects in MySQL are never case sensitive. Generally speaking, tables are case sensitive. And I always recommend lowercase your tables as a matter of course. Because when you're running select statements, there's nothing more frustrating than having selects fail simply because a table is in title case when it's actually lowercase or vice versa. Anyway, create table space, lowercase table name, no spaces. And then we open it up with a parentheses. And by the way, this is completely standard ANSI ISO SQL syntax. Pretty much exactly what you'll find on SQL Server or Oracle. Between the parentheses and finishing with a semicolon, we have our column declarations, our column names, at least one space, our data types, for data types that require some parameter, like for a string value, we have our width, char5, so this is going to be a fixed length string. Integer, here we're not specifying a length, we're letting the default handler take that, so it's going to go all the way to the end. Unsigned, and then we have a nullability statement here. We're going to talk more about null and nullability in a future nugget. I'll leave that go right now. Note that we need a comma after every column identifier. So we've got what's going to be our primary key column, I'm sure, because we're dealing only with positive integers that cannot be empty. That's what not null means. We have to have a value for every row in the ID column. Second column is called col1. It's going to be a char 5, and we're specifying the UTF-8 character set. This is an option. Note that after we name the column and give it a data type, these are required. We can provide additional options like null or not null, character set. We can provide additional integrity constraints. Col2 is using the date data type, and we're using a default option here. The default date for this column is evidently June 1st, 2009. We finish with the closing paren, semicolon, and we've got ourselves a new table, and we're ready to do other things with that table. Of course, we can do data input, data entry. We can build an index on that table, and so forth. Down below, I've given you some additional options. Auto increment is an excellent thing to add to this initial column. That's going to automatically increment those columns, or the column values, I should say, so that the data entry operator doesn't have to think about it and doesn't have to worry about it. Another thing, as I alluded to in an earlier whiteboard, is attaching the primary key constraint to that ID column to make sure that not only are we automatically incrementing and filling in values for that important column, but that we never get a duplicate value. Another important option potentially is to add or swap a storage engine. We'll talk more about storage engines as we go along. MySQL supports pluggable storage engines. Each storage engine in MySQL has a little something different to offer. So tables can run different storage engines to be optimized for different scenarios. This makes MySQL a highly customizable database system. I'm a motorcyclist myself, so I always think of MySQL as kind of the Harley Davidson of relational database systems. It's infinitely customizable to your own personality, much in the same way a Harley is. It's time for our demo. Let's put theory into practice now. What we're going to do is log into MySQL, create a table, and thereby implement the data types, or at least a few of them, that we've been talking about thus far. Let's get to work. Okay, here we are on MySQL Nugget, our Windows Server 2008 machine, and we're going to demo using data types. Before we get started, though, there was some unfinished business from a previous Nugget, something interesting I wanted to show you, dealing with MySQL logins and making them a little bit easier. Thus far, we've been logging into the MySQL client program by using the long syntax MySQL uroot and then with -p. That's all well and good. However, for the duration of this training, to make things faster, I wanted to show you an alternate way to go. Now, this is something you'll only want to consider on a secure system. For instance, if you have the MySQL client tools installed on your workstation, you may want to look for the location of your option file, which will be by default in your working directory. On my server, that's C program files, MySQL, MySQL Server 5.1, there's my.ini, and in that file, you'll find a section called Client. And in the Client section, by default, there's just one value, that's the port on which the server is listening. But you can add 3 additional values, host, user, and password. Now again, the reason for this being something that you'll want to be very carefully guarding is obvious, because the password, the connection password, is stored here in plain text. So you can specify a local or remote host, username, and password, and when you fire up the MySQL client on your local machine, the MySQL client will automatically look for that option file, those client values. Let me bring that back up. So therefore, I will go localhost because my server is in fact running on the local host, and I will attempt to log in as root with this password. And sure enough, if I bring up my command prompt window and simply type MySQL with no further parameters, I'm in. Now I can verify who I am by making a select statement against a user, just a standard MySQL function called user. This is something you should know as a MySQL DBA. you can run select not just against your tables to bring back rows, but you can run select against a whole bunch of built-in MySQL functions to retrieve a single value in response. User is an example of what's called a scalar function. Scalar means that it's a function that brings back a single value. So I'm coming back as root at localhost. In MySQL security, user IDs are always referred to as two parts: the user, at, and then where they're coming from. In my case, I'm coming from the local host, and my user ID is root. Good and good. Now then, let's get started with our data types. First thing we're going to do is create a simple database. So I'm going to say create database MyDB. That's fine. And we'll show databases. Get comfortable with our MySQL syntax here. And you see MyDB there. Now, in order to build a table and start making use of data types, we have to shift our focus to our new empty database. So we'll use the use statement to shift our focus there. And we can say show tables and verify that this is in fact an empty database. So let's get started with the create table statement. To create a new table, we're going to just specify its name. I'll call this test1. Now note that I can press enter and my SQL monitor gives me a new line. We just see another arrow. This is something that confuses folks. When they submit a query, sometimes by just pressing enter, they don't expect to just see another arrow. By the way, if you're kind of stuck and you don't know what to do next, you can use the \C escape character to escape or abort the current operation. This is an important thing for you to understand. So if you're in the middle of a complex query, or maybe even not a complex query, and you just want to back out and get back to your MySQL command, try that \C escape character. Now I'm going to use the up arrow key a couple times and we'll start again. So I'm going to say create table test1, open parentheses, and then let's just start defining our columns. I'll just say col1 space, and why don't we make this varchar 255, comma. We'll say col2, we'll make this char10. See, it's very easy, very quick. We'll do col3, int 10. Of course, you're going to want to plan all this out before you actually do it. I'm just showing you really quickly how to do this. Col4, we'll do date time, and that's all there is to it. To wrap things up into a bow, we'll do a closing parentheses, semicolon, and that's all there is to it. We can now do a show tables, and we've got ourselves test1. We can run select star, or as some DBAs say, select splat from test1, and there's nothing there, of course. We would have to insert, to use the DML command insert, to put some data into that table. Let's do one more table here. We'll say create table test2, and this one will just have a couple columns. Let's create an ID column that's integer, and we won't specify a width here. We're going to throw in some options here. We're going to say not null, and let's also use the auto increment option and throw in primary key. So we're going to throw in quite a few options here. And let's create a second column called data, and we'll make this varchar 50. How's that? Close it up. Now if you make a syntax error, which I did here, we can rest assured that that entire operation failed. Let's do a show tables to verify. Sure enough, test1. And I believe I see the problem. Again, it's a space issue, isn't it? Test space 2. So let me go ahead and repeat the syntax here. That went better, didn't it? So now we've got test1 and test2. Let's use the insert statement to insert some data. Now because of that auto increment, we should find that the ID value gets automatically populated. I shouldn't have to put in any data in that first column. Now we haven't covered the insert statement yet. We're going to do actually a separate nugget dealing with just that. So I'm going to say insert into test2, and I'm just going to put data into that second column called data. And the values I'm going to put in are just hi there. Okay, so if I do a select all from test2, you see, sure enough, that ID has been populated with 1 and data now contains my string. And we could rest assured that as I add additional rows to test2, ID1 will be populated. In fact, why don't I do that again? There we go. Finally, let me use the describe command. If we use describe against one of those tables, we can get a run of those columns. They're called field in MySQL syntax. Some DBAs, old salt DBAs, might argue and say a field is not necessarily a column, a field and a domain. Again, no point in arguing. We're here to pass our exam, right? Field is our column, the data type, whether nulls are allowed, the key value, whether defaults have been defined, and then any extra parameters. Describe is a very helpful command that you should be aware of. We'll finish with a flourish with the quit command. We'll use quit. We're back to the Windows desktop, and we're finished. Understanding data types review. In this nugget, I gave you what I hope was a thorough foundation to the basic building block of the building block of database design in MySQL. The building block of a relational database system is in fact the table. The building block of the building block is the column, and more specifically, the data type. I showed you how to use data types in table columns and what those fundamental data types are. You should be familiar with strings, numerics, and date-time data types now, and be prepared to move on and implement those data types in all of the different objects in the MySQL world. I hope that this has been informative for you, and I'd like to thank you for viewing.